So the way this works is that stuff gets given to me, information, and I got to try to translate it. I think I try to do it so that I can control it. I don't use maths, I just use visualization techniques, but I need to know it's standing fully on mathematics. So I've taken a visualization from Leve in order that I could understand atomic energy, and this morning it came to me. Let's go. So here's Leve. You remember Leve starts from 5 cases, and we bring it to 6 cases for balance of position and load. And I was seeing an imbalance. Look at the way this goes. This is half a rotation. This is one rotation. This is the second rotation. So it goes round. When it goes round once, this position is ending up here in the wave. This is representing time now at the moment as the load breaks. It starts here, then it goes here. All this action happens at the same time in a duration of 8 seconds, but nonetheless it's cause and effect. So it goes, force happens here. And it's going to create, it goes the load goes one, split, nothing. This will be the point that it will burst. There's no force. The force has done its work, it's run out. Over here, you can see this is after one rotation. So this is an empty space representing this empty space. And so the force is now still here, still existing, doing its work down here in the wave. And so hit force 1, 2, 1, 2. Now, this is where the end of the wave, end of the moment occurs, and a new moment must begin. We know a new moment begins with a force. So where's that force created? This should be the odd one out, because this is the only place in the cycle where you get 3 loads. You get 3 loads going on. Here we've only got 2. So what it means is there must be a force for the next moment must be here. So what I mean by balance, it's confusing, don't worry about it. I'm just trying to represent both from plan view and cross-sectionally how this wave would develop in the moment so that I could see what was happening here in the force. What is this force? There must be one because we see it acting. So what is it? It's nuclear energy. And that's caused by the positive motion, the positive moment. You've got, let's have a look at AB5 from Leve, which I've decorated. So the straight lines represent bending within the moment, a suspension of a beam, if you like. The bending means it's a beam in one place. There's no bending in this. This is just motion. This is like a bubble about to burst. Because it's off center, it's spinning anti-clockwise. It's actually falling this way because its gravity is pushing it. It's got a weight, a mass. It's going to fall that way. So it's pulling the axis offline. So this is where the alpha comes from. The 137 arc seconds is here as that spinning force pulls its axis offline. And so you end up with, it's at position 4, you're positive. This is the positive moment. And so from that perspective, as the thing now starts to run out, you're going to go from positive to negative, and then it earths because you should be bursting, but something's happening instead because of this force change and angle. You earth, it goes positive to negative, earth, bang, spark. When you earth out a charge, you get a spark. And so if you bring that into the kind of illustration for the moments I was talking about, so I've just split this pattern of the wave back to Leve, but added where the force is being created, and it's here there. So imagine this is that space here. A spark is created. That spark is trapped. It's going to be trapped because the loads of the waves above and below it are coming through. This is one wave, 1, 2, 3. This is the other wave. Sorry, ABC. This is DEF. This is the second motion of the wave. Here is the spark trapped by its loads, and so it creates the moment here. And here are those 3 loads now. It's not. Yeah, you see the difference? It's filled that space, and this is where angular momentum is created. This is spinning, so it's added a little boost right at the very end, and it begins again. So that the boost occurs here in B12, creating the force and the spin. And it's made of something, it's made of water, because this reaction between previous moment and next moment is that the energy for the next moment is created in the previous moment from the positive moment. So positive moment, create the spark, next moment, it's called superheated steam. And it's trapped. This is the replication of the nuclear fuse, where you've got a zero, effectively, temperature on the outside and a maximum temperature on the inside. You've got K and you've got zero. So you've got max and nothing. What happens is the spin then allows this water, in that one beat, the first motion of the wave, this is gone. It remains in the previous moments. You don't carry the radioactive nature that's created the energy. That stays behind in the previous moment, and you just get pure water that enters into the cycle and drives the whole wave of the atom. If you build a fuse, use uranium, make this at this position, if you corrupt that load at 1,2, if you make that weak, if you fill that void with a decaying piece of radioactivity from uranium, it means there's nothing there. You've just filled that hole. And what happens is that you get the energy from here being released into space-time, and you get a huge explosion. It looks like a mushroom cloud because it's going to do the next motion of this torus shape is going to be what is released. It's going to come out from there to there. So that's the duration of time inside Planck's constant. This is measured by h. That's half h, 1 rotation. That's the rest of h, 2 rotations. So in this tiny, tiny, tiny subatomic load pattern, if you just break that, you release the power that drives reality and radioactivity. Oh, wow, so I thought that was really exciting because it proves that in 1915, German physics had the secret of atomic energy and then chose to give us general relativity instead, indicating that they chose to lie to us so that they could corrupt all this power and use it for themselves. And everything that's happened since that moment has been a lie. So an important document. All I can say is look at it, think about it. How do I know this? How do you think? Love rules. Do the work. Cheers.